Hello students, in this lecture we will study the star-delta conversion. Sometimes it is also called as the Star-Delta Theorem. With the help of star-delta conversion, we can convert a star connection into equivalent delta and the delta can be converted into equivalent star. The meaning of the equivalent means the resistance between the 2 points either in star, either in delta, it will always remain same. First of all, we will see what is the star connection and what is the delta connection. See here, this is the star connection. Say, there are the three resistances. Say, this is the R1, this is the R2 and this is R3. Here S, it is the starting point, F, it is the finishing point. Similarly for the second, S start, F finish and so on. Clear? When we say the star connection, that means the similar ends are joined together. You will see star, that is the similar ends are joined together. That means if we join the all starting or the finishing end, it is called the star connection. And this is the common point. Clear? And this common point, it is known as the star point. It is known as the star point given by capital S. Clear? You will see the star connection R1, R2 and R3, and this is the star point where the all three resistances are meet here. Clear? In AC circuit, R1, R2 and R3, it can be replaced with the impedance Z1, Z2 and Z3. Clear? Here, see this connection. Here this is the common point for all three resistances. That means it is also a star connection. Clear? This is also a star connection which is also known as the T connection. You will study in the transmission line what is the pi connection and T connection. Then this is called the T connection. Here this is the common point and this is the star point. Clear? In three-phase supply, when we say this is the star connection, then always remember here the angle between the two resistances, it must be the 120 degree. Clear? But in network, there must be a common point and it is not necessary the angle between these resistances 120 degree. Clear? It will be 120 degree in the three-phase star connection. Clear? Because where the three coils are displaced at 120 degree to each other, or you can say these three resistances are equally spaced in the space angle. As you know, the space angle is the 360 degree divided by the 3 and you are getting the 120 degree. Clear? So this is the star connection, this is the star connection and this is the star connection. Clear? Similarly, we will discuss the delta connection. We are going to discuss the delta connection. In delta connection, D for delta, and it is the dissimilar ends are joined together. Clear? You see the start end of the first is connected to the finishing end of the second, start end of the second is connected to the finishing end of the third, and the starting end of the third is connected to the finishing. Clear? Similarly, if you start from the finishing end, then finishing end of the first is connected to the start end of the second, finishing end of the second is connected to the start end of the third, and the finishing end of the third is connected to the starting end of the first. Clear? If you will see, if we are putting a ball here, then it will be come out. Clear? Here, if we put a ball here, then it can be come out from this side. Clear? That means this star connection, it is also known as the open connection, where if we put a ball here, there is no way to come out from this connection. Clear? And that means this will be the closed connection. The star connection, it is the open connection, and the delta connection, it is the closed connection. Clear? The star connection is also known as the Y connection, and the delta connection, as you know, it is the delta, and it is given by this triangle, that is the delta connection. It shows that it is the closed path. Clear? Here you will see this is the R12, R23 and R31. Clear? ध्यान से देखिए, here the star point. Clear? यहाँ 1 है, ये 2 है और ये 3 है, तो इसको nomenclature क्या किया हमने? R1. Clear? Here this is the R2, here this is the R3. Clear? Here the R12, it is connected in between 1 and 2, it is the R12. Clear? You can write it is the R21, but for easiness we are considering a sequence, that is the 1, 2 and 3. 1, 2, 2, 3 and 3, 1, and 3 phase supply, it is known as the phase sequence. Clear? You will see when we derive the star to delta conversion and the delta to star conversion, you will see it is very easier to convert the star into delta and delta into star. Clear? You will see this is the delta connection, this is the delta connection, and this is the delta connection. Clear? In transmission line, it is the pi connection. In the star transmission line, the star connection is called the T connection. That means the T connection can be converted into the pi connection, and the pi connection can be converted into the T connection. Clear? Now we will see how we will convert the star to delta and delta to star. Now we will derive the Star-Delta Theorem, by which we can convert the star into delta and delta into star in the network solution. Clear? Because it is very much useful conversion in the network. Sometimes we have to convert star into delta, and sometimes we will convert delta into star, which we'll see in the examples of this Star-Delta Theorem. Clear? Now you will see this is the star connection, this is the R1, this is the R2 and this is R3. This is R12, R23 and R31. Clear? Now we will derive the parental equation. We will derive the parental equation. Clear? What is the parental equation? The resistance in between 1 and 2. Clear? That is the R1 plus R2, that is equal to the R12 into R23 plus R31 upon R12 plus R23 plus R31. Clear? You will see the resistance between 1 and 2, that is the R1 plus R2, and in this R23, R31, these are connected in series. The combined resistance of this series is the R23 plus R31, and it is parallel with R12, and you know that the parallel connection R, that is equal to the R1 R2 upon R1 plus R2. Clear? That's why we are writing R1 plus R2, that is equal to the R12 into R23 plus R31 upon R12 plus R23 plus R31. This is the equation number 1. Clear? Now you will see we are putting the equal. Why we are putting the equal? Because in conversion we have taken this that the star is converted into equivalent delta and the delta is converted into equivalent star. That means the resistance between the 2 points, it will remain unchanged. Either it is the star connection or it is the delta connection. Clear? That's why we are writing R1 plus R2, that is equal to R12 R23 plus R31 R12 plus R23 plus R31. Clear? Now you will see R1 plus R2, then what is this? This is the R12, then you can write similarly. Similarly, R2 plus R3. ठीक है? तो R1 plus R2, that is the R12. Here it will be the R23. What is the R31 plus R12 upon R12 plus R23 plus R31. This is the equation number 2. Clear? And R3 plus R1, that is equal to the, क्या होगा बेटे? R2 plus R3, R23. Here the R3 plus R1, that is the R31, and it will be the R12 plus R23 upon R12 plus R23 plus R31. This is the equation number 3. Clear? That means by using these 3 equations, we will derive the conversion. Either it is the star to delta or delta to star. Clear? First of all, we are converting the delta into star. Delta into star. Clear? You will see delta into star. That means delta में जो रेजिस्टेंस है वो कौन कौन से हैं? R12, R23 and R31. Clear? And in star it is the R1, R2 and R3. Clear? When we say this is the star, clear? Then star में known values R1, R2, R3 and the unknown values in delta, that will be R12, R23 and R31. Clear? So first of all we are converting the delta into star. That means we have to write the R1, R2, R3 in term of R12, R23 and R31. Clear? You will see, first of all, we will add all 3 equations. Clear? That is the twice of R1 plus R2 plus R3, that is equal to the twice of R12, R23 plus R23, R31 plus R31, R12 upon R12 plus R23 plus R31. Clear? Now the 2 and 2, it is cancelled out. Clear? Now put the value of the R2 plus R3. What is the value of the R2 plus R3? That is the R1. Clear? R2 plus R3. This is the R23, R31 upon R12 plus R23 plus R31 plus R23, R12 upon R12 plus R23 plus R31, that is equal to the R1, R12, R12, R23 upon R12 plus R23 plus R31 plus R23, R31 upon R12 plus R23 plus R31 plus R31, R12 upon R12 plus R23, 23 plus R31. Clear? Yes. Now you will see R1 plus R23 R31 upon R12 plus R23 plus R31. Here R23 R31, that means it is cancelled out. Similarly R23 R12 R23 R12, it is also cancelled out. Clear? Then you will get what is the value of the R1, that is equal to the R12 R31 upon R12 plus R23 plus R31. Clear? Now see R1, यहाँ पर R12 और R31, यानी कि हमें वही रेजिस्टेंस लेना है जहां पर 1 आ रहा हो. ठीक है ना? दोनों में कितना आना चाहिए? 1. तो R1 that is equal to R12 R31 upon R12 plus R23 plus R31. Clear? Similarly, you will get the R2. Clear? That is equal to the R12 R23 upon R12 plus R23 plus R31. And what will be the value of the R3? That is equal to the R23 R31 upon R12 plus R23 plus R31. Clear? Now see, if this delta connection is given in the network and we have to convert this delta into star, then you will see, first of all we will mark the common point. Say the common point is S. Clear? What is the common point? It is the S. Clear? When we add this 1 to this S, then this will be your R1. Clear? Then the value of the R1. See, at 1, what are the resistances joining? R12 and R31. That means product of R12 and R31 upon sum of the 3 resistances. Clear? Similarly in R2, if we have to find the value of the R2, this is the R2. Clear? So 2, then you will see R12 and R23 are joining, then it will be the product of R12, R23 upon sum of the 3 resistances, R12 into R23 upon R12 plus R23 plus R31. Clear? Similarly, if we have to convert, find the value of the R3, then 3 पर कौन-कौन से रेजिस्टेंस ज्वाइन हो रहे हैं? R23 and R31. That means the product of the R23 and R31 upon sum of the 3 resistances, that is the R23 R31 upon R12 plus R23 plus R31. Clear? Any doubt? Clear? Now you will see. Say this R12, say this is the X, this is the X, and this is the X. That means a delta connection. Say X, X, X. Now we have to convert into the star connection. Then what will happen? X into X. Clear? So X into X upon X plus X plus X, that is equal to the X square upon 3X, that is equal to the X upon 3. Clear? That means these resistances will be X upon 3, X upon 3, X upon 3. Clear? That means if a delta connection having the equal resistances, when we convert into the star, clear, it will become 1/3 of the value. Clear? Now you will see, say, this is the delta connection. This is the delta connection. Say this is the P, this is the Q, and this is the R. Say this is the 3 ohm, this is the 6 ohm. Clear? And this is the 9 ohm. We have to convert this delta into star. Then what will happen? We have to convert this delta into star. First of all, mark the S point. Clear? Then what will be the value of this? At P, the resistances are 3 and 9. That is the 3 into 9 upon 3 plus 6 plus 9. that is equal to the 27 upon 18. Clear? Similarly, what will be the value of this resistance? 3 and 6 are combining, that is the 3 into 6 upon 3 plus 6 plus 9, that is equal to the 18 upon 18 ohm. Clear? And here the value of this resistance, it will be the 9 into 6 upon 3 plus 6 plus 9, that is the 54 upon 18, that is the 3 ohm. Clear? It is the simple example how we will convert a delta into a star. Clear? Now we will see, now we will convert Now we will convert star to delta. When we convert star into delta, then the unknown values are R12, R23 and R31, and the known values are R1, R2, R3. You know that these are the parental equation, and we derived from delta to star R1, R12, R31 upon R12 plus R23 plus R31 and so on, which resembles in the A, B, C. Clear? Now multiply 1 and 2, sorry, A and B. Multiply A and B, comma, B and C, comma, C and A. Clear? When you are multiplying the A and B, then see R1 into R2. Then you are getting the R1 into R2, that is equal to the R12 square into R23, R31 upon R12 plus R23 plus R31 whole square. Clear? R12 plus R23 plus R31. यहाँ पर भी R12 plus R23 plus R31. When you multiply, then it will be the square. Clear? Here you will see R1 into R2. Here the square is R12. Then what will happen? R2, R3. R2, R3. Then it will be the R23 square, R31, R12 upon R12 plus R23 plus R31 whole square. Similarly, R3, R1, that is equal to the R31 square into R12, R23 upon R12 plus R23 plus R31 whole square. Clear? When you will add all three equations, then you will get R1, R2 plus R2, R3 plus R3, R1, that is equal to the R12, R23, R31. सब में से कॉमन आ जाएगा. Then you will get R12, R23, R31 upon. Clear? R12, R23, R31 और कॉमन क्या क्या आएगा बेटे? R12 plus R23 plus R31 upon R12 plus R23 plus R31 square. Clear? Now it will cancel it out. Clear? That means you are getting the final equation. It will be R1, R2 plus R2, R3 plus R3, R1 is equal to the R12, R12, R23, R31 upon R12 plus R23 plus R31. Clear? Now you will see R12, R23, R31, R12 plus R23 plus R31. Clear? Any doubt? Now you will see we have to find the value of the R12. Clear? Now you will see What is this? This is the R23 R31 upon R12 plus R23 plus R31. If you examine the equation A, equation B and equation C, then R23 R31 upon R12 plus R23 plus R31, what is this value? This is the R3. Clear? Or you can say R12 is equal to the R1 R2 upon R3. Clear? Plus R2 R3 upon R3 plus R3 R1 upon R3. Clear? This R3 cancelled out, this R3, this cancelled out. Then finally we can write R12, that is equal to the R1 plus R2 plus R1 R2 upon R3. This is the value of the R12, that is equal to the R1 plus R2 plus R1 R2 upon R3. Clear? Now you can write easily. Then what is the value of the R23? R23. Clear? R12, R1 plus R2. Then what will happen? It will be the R2 plus R3 plus R2 into R3 upon R1. Any doubt? Clear? And that is the R31, that is equal to the R3 plus R1 plus R3 R1 upon R2. This is the conversion. Any doubt? Now you will see. Say R1, R2, R3 is given. This is the star. Now we are converting into the delta. Clear? We are joining. This is the blue line. हमने इसको join किया तो क्या है बेटे? R12. Clear? Then always remember R1 plus R2. Clear? That is the R1 plus R2 plus product of both. That is the R1 R2 upon divided by the remaining resistance, that is the R3. Clear? For example, say this is the X ohm, this is the X ohm. Clear? And this is the X ohm, and we have to convert into delta. Clear? Then what is the value of the R12? That is the this plus this, X plus X plus product of this, X into X upon this X, and you are getting the R12, that is equal to the 3X. Clear? That means when the star is converted into the delta, the value of the resistance, it will become 3 times. Clear? For example, this is the, we are putting the X, say this is the 3 ohm. Clear? Say this is the 6 ohm, 6 ohm, and this is the 9 ohm. Clear? Then what is the value of the R12? What is the value of the R12? That is the R1 plus R2. Clear? That is the 3 plus 6 plus 3 into 6 upon remaining resistance 9 ohm. That is the 3 plus 6 plus 18 upon 9, that is equal to the 3 plus 6 plus 2, that is the 11 ohm. Clear? Similarly, you can find the value of the R23. Clear? करके देखिएगा. R23. What is the R23? 2 and 3. Clear? The sum of these resistances, 6 plus 9 plus 6 into 9, remaining resistance is 3 ohm upon 3. 3 2s are 9 2s are 18, 18 and 15, that is equal to the 33 ohm. Clear? Similarly, you can find the value of the R31. Clear? This type of conversion, this type of small question, it is asked in the objective questions, in university examination, and also asked in the competition examination. Clear? Now it is clear that how we will convert the star into delta and delta into star. Clear? Today we discuss the conversion. We derive the theorem that how we will convert the star into equivalent delta and delta into equivalent star. Clear? In next lecture, we will discuss some important numerical problems in which we will see how we will convert the star into delta. Sometimes you will find in a numerical, first of all you will convert the star into delta, then delta is converted into star, and again the star is converted into delta. Means many times we will use this conversion, star to delta and delta to star. Clear? Now tomorrow in the next lecture we will discuss the numericals problem on the Star-Delta Theorem. Clear? If you have any doubt, any problem, you can mail me.